Right. How are you doing, guys? Today I'm going to tackle the day 5 of the Advent of Cyber 2024 from TryHackMe. So let's get to it. Day 5, SOC Mass XXE. Okay, what is that? The days in Warville flew by, and software projects were nearly complete, just in time for Christmas. One evening, after wrapping up work, software was strolling through the town when he came across a young boy, looking dejected. Curious, Software asked, "What would you like for Christmas?" The boy replied with a sigh, "I wish for a teddy bear, but I know that my family can't afford one." Okay. This brief conversation sparked an idea in Software's mind. What if there was a platform where everyone in town could share their Christmas wishes, and the mayor's office could help make them come true? Excited by the potential, Software introduced the idea to Mayor Malware, who embraced it immediately. The mayor encouraged the team to build a platform for the people of Wareville. Through the developers' dedication and effort, the platform was soon ready and became an instant hit. The townspeople loved it. However, in the rush to meet the holiday deadline, the team had overlooked something critical: thorough security testing. Even Mayor Malware had chipped in to help develop a feature in the final hours. Now, it's up to you to ensure the application is secure and free of vulnerabilities. Can you guarantee the platform runs safely for the people of Wareville? Learning objectives: understand the basic concepts related to XML, explore XML External Entity XXE and its components, external entity. Explore XML, which is external entity. Okay, and its components. Learn how to exploit the vulnerability, understand remediation measures. Important concepts. Extensible markup language. Okay, XML is a commonly used method to transport and store data in a structured format that humans and machines can easily understand. Consider a scenario where two computers need to communicate and share data. Both devices need to agree on a common format for exchanging information. This agreement format is known as XML. You can think of XML as a digital filing cabinet. Just as a filing cabinet has folders with labeled documents inside, XML uses tags to label and organize information. These tags are like folders that define the type of data stored. This is what an XML looks like: a simple piece of text information organized in a structured manner. People, name, address, email, phone. Yeah, okay. In this case, the tags people, name, address, etc. Are like folders in a filing cabinet, but now they store data about glitch, right? The content inside the tags, like glitch, Wareville, and this number represent the actual data being stored. Like before, the key benefit of XML is that it is easily shareable and customizable, allowing you to create your own tags. Okay, document type definition, DTD. Now that two computers have agreed to share data in a common format, what about the structure of the format? Here is when DTD comes into play. A DTD is a set of rules that defines the structure of an XML document. Just like a database scheme, it acts like a blueprint, telling you what elements or tags and attributes are allowed in the XML file. Think of it as a guideline that ensures that the XML document follows a specific structure. For example, if we want to ensure that an XML document about people will always include a name, address, email, and phone number, we would define those rules through DTD as shown below. Doc type, element people. Uh, okay. Name, address, email, phone, and then the element name. This data. Okay. So through this is just a set of rules, right? In the above DTD, element means defines the element tags that are allowed, like names, address, email, and phone, whereas PC data stands for parsed people data, meaning it will consist of just plain text. Okay. Entities. So far, both computers have agreed on the format, the structure of data, and the type of data they will share. Entities in XML are placeholders that allow the insertion of large chunks of data or referencing internal or external files. They assist in making the XML file easy to manage, especially when the same data is repeated multiple times. Entities can be defined internally within the XML document or externally, referencing data from an outside source. For example, an external entity references data from an external file or resource. In the following code, the entity @x could refer to an external file located at tryhackme.com robots.txt, which would be loaded into the XML if allowed by the system. Doctype entity x, okay, system this, people glitch, okay. We're specifically discussing external entities because it is one of the main reasons the XXE is introduced if it is not properly managed. So then comes XML External Entity. After understanding XML and how entities work, we can now explore the XXE vulnerability. XXE is an attack that takes advantage of how XML parsers handle external entities. When a web application processes an XML file that contains an external entity, which is the case for this one, right? What happens? The parser attempts to load or execute whatever resource the entity points to. If necessary sanitization is not in place, the attacker may point the entity to any malicious source code causing the undesired behavior of the web app. For example, if a vulnerable XML parser processes this external entity definition, entity THM file system, okay. Uh, Here, the entity at THM file refers to the sensitive file its password on a system. When the XML is processed, the parser will try to load and display the contents of that file, exposing sensitive information to the attacker. In the upcoming task, we'll examine how XXE can work and how to exploit it. Connecting to the machine. Before moving forward, review the questions in the connection card shown below. Okay. Do I need to start the attack box today? Yes. Do I need to start the VM today? Yes. Is there a split screen available? No. Is there a direct link available? Okay, let's start the machine already. Practical. Now that you understand the basic concepts related to XML and XXE, we'll analyze an application that allows users to view and add products to their carts and perform the checkout activity. You can access the Wearables application hosted on this particular IP address, which is just loading. This application allows users to request their Christmas wishes. Okay, so what I'm gonna do is disconnect to the VPN. Ooh, why am I like this? Galaxy, yeah, TryHackMe, yeah, Advent of Cyber. No, make here day 5. This is day 5. This is day 5, right? Yes, day 5. Okay. Oh, my eyes. All right, let's get to it. Practical knowledge, you understand the basic concepts related to this. Okay, we're still waiting for this to boot up. Now, what it is that we will have to do? Let's check this out real quick. This application allows users to request their Christmas wishes. Yeah, sure. So it's okay. Wearable view. Welcome to Wishbill. So let's view the teddy bear. Add to wish list. Item added to your wish list successfully. Okay. So flow of application. As a penetration tester, it's important to first analyze the flow of the application. First, the user would browse to the products and add items of interest to their wish list at product.php. Yeah. Click on the add to wish list under Wearable's Jolly Cap as shown below. After adding products to the wish list, click the cart button. Where's that? The cart button or visit cart PHP. I can't see no. Oh, yeah, here. Or visit this and to see the products added to the cart. On the cart page, click the proceed to checkout. Okay. And then to buy the items as shown below. On the checkout page, the user will be prompted to enter his name and address as shown below. Glitch, temporary Wearable's address. Oh. Okay, complete checkout. Wish successful. Your wish has been saved as wish number 21. Okay. Yeah, as shown below. Yeah. Wish number 21 indicates the wishes placed by a user on the website. Once you click on wish number 21, you will see a forbidden page because the details are only accessible to admins. Okay, so let's click on this. And we should get an error sent us. Elves are the only ones who can read the wishes. Okay, I see you. But can we try to bypass this and access other people's wishes? This is what we'll try to perform in this task. Okay, intercepting the request. Okay, so it looks like we're gonna be using Burp Suite, which is alright with me. You know what? I don't know why this happened like this. Okay, intercepting the request. Before discussing exploiting XXE on the web, let's learn how to intercept the request. First, we need to configure the environment so that as a pen tester, all web traffic from our browser is routed through Burp Suite. This allows us to see and manipulate the request as we browse. We'll use Burp Suite, a powerful web vulnerability scanner, to intercept and modify a request for this exploitation. You can access Burp Suite from the attack box. On the desktop of the attack box, you will see the Burp Suite icon. Okay, I already clicked on it. I already started it. Okay. I also understand that we are gonna be using the dashboard. Proxy, intruder, and repeater. Okay. You will see the main interface with different tabs, such as this. Inside Burp Suite, click the Settings tab at the top right. Yeah. And you will see Burp Suite option available under Tools. Enable Allow Burp Browser to run without a sandbox option. Why would I do that? And click on the close icon at the top right corner of the Settings tab as shown below. I mean, uh, you're telling me to go to the Tools section, and then on Burp's Browser, you're asking me to enable Allow Burp Browser to run without a sandbox. Use these settings to control whether Burp's browser can run without a sandbox or attempt to use the GPU. And click on the close icon. Okay, after allowing the browser to run without a sandbox, we will now be able to start the browser with pre-configured Burp Suite's proxy. Navigate to the Open Browser option located at the proxy intercept. Okay, let's click on this. Then let's open browser option. Yeah, show me don't browse to the URL to the particular IP, right? Open browser. If we go to the IP, we get this. Okay, so that all requests are intercepted. Yeah, once you browse the URL, the requests are intercepted and can be seen under the proxy HTTP history. Browse proxy HTTP history. Yes, we can. We can see everything in there. Okay. What else? What is happening in the backend? So now, when you visit the URL, uh, the URL IP plus product.php and click on the add to wishlist, an Ajax call is made to wishlist.php with the following XML snippet. Is it in the above XML? So let's do that. Like, let's access our browser. Let's add this. Add to wish. Chrome didn't shut down correctly. Yeah, no biggie. Add to wish list. Item added to your wish list. And then if we go to cart, then I proceed to checkout. Test. Wish you have your wish has been saved to wish number 22. Continue shopping, right? So yeah. So what were you saying here? That in the above XML product ID tag contains the ID of the product, yeah, which is one in this case. Now let's review the add to wish list request logged in Burp Suite's HTTP history option under the proxy tab as discussed above. The request contains XML being forwarded post request as shown below. So there is a post request here to the wishlist.php, right? Yes. Okay. What else? And okay, so if we check it out, then we see user ID 1, product ID 1. Okay. Yeah, this wishlist.php accepts the request and parses the request using the following code. PHP, live disable entity load or false, wishlist equals simple XML load string, XML data, simple XML element, live XML no entity. Echo item added to your wishlist successfully. Okay. Accepts the request and parses the request using the following code. How do you know? How do you know that's the code that it uses to parse the request? Okay, I guess you're just telling me, right? And parse the request using the following code. Okay, preparing the payload. When a user sends especially crafted XML data to the application, the line live XML disable entity load or false allows the XML parser to load external entities. This means the XML input can include external file references or requests to remote servers. When the XML is processed by simple XML load string with the live XML no ent option, the web app resolves external entities, allowing attackers access to sensitive files or allowing them to make an internet request from the server. So what if we update the XML request to include references for external entities? We will use the following XML instead of the above XML. To include references for external entities. Okay. Yeah, so we would be adding that particular thing in the XML version, and then doc typeful edit payload system on the particular path, right? When we send this updated XML payload, the first two lines introduce an external entity called payload. Yeah. The line entity payload system. Its host tells the XML parser to replace the payload So with here, reference went with the contents of the file at C hosts on the server. When the XML is processed, instead of a normal product ID, the application will try to load and include the contents of the file specified in the entity at C hosts. Okay. Exploitation. Now let's perform the exploitation by repeating the request we captured earlier. The Burp Suite tool has a feature known as Repeater that allows you to send multiple HTTP requests. We will use this feature to duplicate our HTTP post request and send it multiple times to exploit the vulnerability. Right click on the wishlist.php post, right click, and I guess send to repeater, right? Now if we go to the repeater, click on send to repeater, yeah. Now switch to the repeater tab where you'll find a post request that needs to be modified. We will update the XML payload with the new data as shown below and then send the modified request. Okay, so it looks like we're gonna make some updates. XML version and then 1.0 and then close syntax and then doc type for entity and then payload system etc hosts and now this and now this and now this. Okay, that should be enough, right? Place the mouse cursor inside the request in the repeater, tap in the Burp Suite and press Ctrl V. What? Place the mouse cursor inside the request in the repeater. Oh yeah, okay. And press Ctrl V or paste the payload in the above highlighted area. Okay, we already did that. When we click send, the server processes the malicious XML payload. Item added to your wish list successfully. Which included the external entity reference to the host as a result. The wish list PHP responded with the contents of the entity. Oh, I forgot to actually update this. So I guess I can do it now. Payload. And what if we send this now? Yeah. Okay, so the following lines are desirable for IPv6 capable hosts. It's invalid. Yeah, we get that as well. The contents file leading to an XXE vulnerability. Time for some action. Okay, I like action. Now that you've identified a vulnerability in the application, it's time to see it in action. MaxKites software has tasked us with finding loopholes, and we've successfully uncovered one in the wishlist.php endpoint. But our work doesn't end there. Let's take it a step further and assess the potential impacts this vulnerability will have on the application. Earlier, we discovered a page accessible only by administrators, which seems like an exciting target. What if we could use the vulnerability we've just found to access sensitive information like the wishes placed by the townspeople? And now that our objective is clear, let's leverage the vulnerability we discovered to read the contents of each wishes page and demonstrate the full extent of this flaw to help MaxKite secure the platform. To get started, let's recall the page that is only accessible by admins. It was wishes /wish1.txt. Using this path, we just need to guess the potential absolute path of the file. Typically, web applications are hosted on var.www.html. With that in mind, let's build our new payload to read the wishes while leveraging the vulnerability. Okay, see you. So let's try that. We're just basically updating the path just to retrieve some sensitive information. What if we send this now? Oh, the product ID, major malware, address test, product, where the, okay. Okay, so we got something. Not, also what else? Then let's build, no, not all web applications use the path var www.html, but web servers typically use it. Okay. Surprisingly, we got lucky that our assumption worked. The next thing to do is see whether we can view more wishes using our discovery. To do this, let's try replacing the wish1.txt with wish2. Sure. What if we send again? Major malware test as well. Wish number 2, yeah. Okay. As a result, we were able to view the next wish. You may observe that we just incremented the number by 1. Given this, you may continue checking the other wishes and see all the wishes stored in the application. After iterating through the wishes, we have proved the potential impact of the vulnerability, and anyone who leverages this could read the wishes submitted by the townspeople of Wareville. Conclusion: it was confirmed that the application was vulnerable, and the developers were not at fault since they only wanted to give the townspeople something for Christmas. However, it became evident that bypassing security testing led to an application that did not securely handle incoming requests. As soon as the vulnerability was discovered, McSkydy promptly coordinated with the developers to implement the necessary mitigations. The following proactive approach helped to address the potential risk against XXE attacks. Disable external entity loading. The primary fix is to disable external entity loading in your XML parser. In PHP, for example, you can prevent XXE by setting elif disable entity loader to true before processing the XML. And then validate and sanitize user input. Always validate and sanitize the XML input received from users. This ensures that only expected data is processed, reducing the risk of malicious content being included in the request. For example, remove suspicious keywords like etc host, etc password, etc. from the request. After discovering the vulnerability, McSkydy immediately remembered that a chain log file exists within the web application and stored at the following endpoint. Okay. Oh, after checking, it can be seen that someone pushed the vulnerable code within the application after software Steam. Major Warbill, yeah. Fix the wishlist.php page. Okay. Major malware backdoors. Okay, with discovery, McSkydy still couldn't confirm whether the mayor intentionally made the application vulnerable. However, the mayor had already become suspicious, and McSkydy began to formulate theories about his possible involvement. After navigating through the wishes. Oh, okay. What is the flagging on the possible proof of sabotage? Wait. Yeah, that goes here. What is the flag discovered after navigating through the wishes? Do you really want me to go through all the wishes? Okay. And number 3, there's no particular flag. What about number 4? No flag. Number 5, no flag. Number 6, no flag. 7, no flag. 8, no flag. 9. I mean, is there a faster way? 10, no flag. 11, no flag. 12, no flag. 13, no flag. What is the flag discovered after navigating through the wishes? There are a lot of times people who submitted their wishes, so they tried the rating up to 20. Yeah, I was just getting there. 14, no flag, maybe 20. The product is invalid. Wish 19, no flag. 18, no flag. 17, no flag. 16, no flag. 15, no flag. Oh yeah, we got the flag in number 16. Come on. Okay, what's next? If you want to learn more about XXE injection attack, check out the XXE injection. Sure, save it, because I do want to dig into this a bit more. And then if you, what else? Following McSkydy advice, software recently hardened the server. It used to have many unneeded open ports, but not anymore. Not this matters in any way. Okay, that's it, guys. We finished the day 5. I will see you on the next day of Advent of Cyber 2024. It was fun. I learned about a new type of vulnerability, right? And yeah, that's that.